In this video, I will demonstrate the camera sync option on the IS8000. This requires you to have the FS1 high-speed camera synchronization option loaded for the IS8000. To demonstrate the camera sync, I'm using a high-speed camera from Photron. A list of compatible cameras is available on the IS8000 product page. I am also using the Yokogawa DL950 scope quarter. The wiring of the camera to the DL950 is shown here from the high-speed camera synchronization option manual. I have an additional camera window set up to show the test setup with the Photron camera, DL950, and accelerometer. I will first open IS8000, then connect both the DL950 and camera by selecting DAC. I'm connected to the camera via Ethernet, so I will type in the IP address. Once I enter that and hit search, the camera will appear. And I can click on both instruments to open. Once I'm connected, I can do some housekeeping and remove some menus and maximize the windows. You can see I have the DL950 and Photron FastCam now connected to each other through the coaxial connection. I have both the device control and channel control settings for each instrument on the right. Since the camera is triggering the scope quarter, I want to configure the trigger on the DL950. I have my triggers position set for 50%, and set the trigger output rate as a pulse width of 50 milliseconds. I will set the external sample output to free run and pulse rate of 50 Hz. Next, I will configure the FastCam. I click Video and Sync Settings. We have the frames per second set to 50, which matches the DL950 pulse rate. There are many options for shutter speed, but I will choose 1/1000 and a resolution 640 by 640. When I adjust the record frames, you will see that the other selections will change to match the number of frames I have selected. When I am done, I'll hit Select Apply. And I'll verify the settings on the DL950 to match the settings I chose before, and I'll click Confirm. Now that we have configured the instruments, I select the Video tab to show the streaming video. I would like to have the waveforms on top of the video, so I can adjust that by dragging the window below. Also, since this is a demonstration, I want to reduce the record length to make it quicker. Let's select 100K. Next, I'll make some adjustments on the channel acquisition. I'll adjust the sample rate. Verify the coupling. Select full bandwidth. Set my gain to 0.5. Bias on. Sensitivity to 1. When I'm done, I'm ready to record. To set my trigger, I'll change the window on the camera so you can see the test setup. In this setup, I have the DL950 waiting to trigger from the camera, as you can see the blinking yellow. And the camera is pointed towards my accelerometer, which is beneath the pink bubble wrap. I'm planning to drop this Ethernet hub on the accelerometer to trigger the scope quarter. And you can see the trigger and acquisition was successful. I'll now switch back to IS8000 view and stop the recording. This will take some time to load depending on the record length you have selected. After we wait a minute, the waveform loads into IS8000's host computer. This is saved as a project, and I will now open up the project to review and analyze post-process. The project file includes the MF4, the AVI, which is the video file, and the one I'm interested in is the ANPJT, which is the project file. When I recall the project file, it will open up the waveform with the video file. When the project loads, I can select the Video tab to display the video with my waveform file. When I hit play, I can select frame by frame of the video to correlate with the waveform acquired from the accelerometer. It's easy to navigate through the video by dragging the bar which indicated which frame I'm viewing and the correlated cursor on the waveform tracks. So I will try to pinpoint the moment of impact on the rising edge of the waveform. Once I've found that spot, I can create a zoom trace, and if I wanted to get higher resolution detail, I can drag the zoom bar and get a lot more waveform detail. So I can see the full record, the zoom record, and once I align this, I can now play through the video again at a coarse resolution above and a higher resolution below in the zoom trace.
We are the precision makers.